Hello everyone, welcome to the next lecture of subject CAD/CAM. This is Mr. Suyog Patil, working as Assistant Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Yadrao, Ichalkaranji. Today, we are going to discuss the NC systems. So, first of all, we will see what is with this mean by this NC machine tool. Okay. So, this NC means the numerical control. NC is any machining process in which the operations are executed automatically in sequences as specified by the program, and that contains the information for the tool movements. Okay, so we can see here in this numerical control is a form of programmable automation in which the mechanical actions of a machine tool or other equipments are controlled by the program containing coded alphanumerical data. Okay, so that means here in this numerical control machines, this all these actions, mechanical actions of a machine, and this all the equipments are controlled by a program, coded programs. Okay, that is called as numerical control machines. Alphanumerical data, it is coded in the alphanumerical data. So again, but this alphanumerical data represented relative position between the workload, work head, and the work part, as well as the other instructions needed to operate the machine. So that means this alphanumerical data which represents this relative position between this work head, that means this work table, and this works part, that means the component or the workpiece. Okay, and which shows these instructions needed to operate the machine. Okay, so again, this work head is a cutting tool or the other processing apparatus, and the work part is the object being processed. The work head means here the cutting tool, and this work part is the object being presented. Okay, so that means this. Then again, the applications of the numerical control machines. So these numerical control NC machines, machine tools, can be used in this operations such as the drilling, milling, then turning, and other metalworking operations. Likewise, welding and arc cutting, also these CNC machines, numerical control machines, you may be used. Then again, in non-machining machine tool applications such as assembly, drafting, inspection, testing, in this application, in such applications also these numerical control machines can be used. Then the common operating feature of the CNC in all these applications is control of the work head movement relative to the work part. That means the main common feature of this numerical control machines is to control this work head movement and work part movement. Relative motion between these two is controlled here. Then we can see this NC systems. The NC system must possesses a means of controlling the relative moment of the tool with respect to the work. Then there are three types of this motion controls used in the numerical control, that is called as point to point control, then straight cut control, as well as the third one, it is contouring control. These are the three main types of this motion controls used in the numerical control systems. And these three types are listed in order of the increasing level of control of sophistication. So that means these are listed in the increasing order of the level of control of sophistication. So we will discuss one by one in detail. So before discussing that, classification of these numerical control machines. The numerical control machines can be classified according to this coordinate systems, then according to the motion control, according to this control loops, power drives, positioning systems. Again, these numerical controls can be classified. These coordinate systems, according to these coordinate systems, this numerical control machine can be flat and can be used for prismatic parts as well as for the rotational parts. Okay, then according to this motion of control, it may be point to point control, it may be continuous or contouring control, path control it is called as sometimes. Okay, then control loops, according to this control loops it may be open loop or it may be closed loop. Okay, we will discuss in detail later on. Then according to these drives, it may be hydraulic, electric or pneumatic drives, numerical control machines may be there. Okay, then according to these positions, absolute positioning and incremental positioning, these are the two types of this numerical controls. In absolute positioning, the movement moves to a coordinate, okay, based on the 0 point. That means in absolute case this movement of this tool or machine is with respect to the origin 0. Okay, but in case of this incremental, this movement moves a distance based on this current position. That means from here to if this tool is moved from point A to B, then it again this moment is considered from B to C, not from original, that is A to C. Okay, but in case of this absolute, it is absolute position, it is considered from the origin, that means A from A to C. Okay, we will discuss in detail. First one, it is coordinate systems. So in this coordinate system, in order for the part programmer to plan the sequence of positions and the movements of the cutting tool relative to this workpiece, it is necessary to establish standard axis systems by which these relative positions can be specified. Okay. Similarly, again we can say the two axes x and y are defined in the plane of the table as shown in figure. Here we can see this axis x and this axis y. Two axes are defined in the plane of this table. This is the work table. Here we can see this is the work table, and these two axes are in the along this plane of this table. And this third axis, z axis, positive and negative z axis, is it is perpendicular to this plane of this table. Okay, it is perpendicular, and this z axis is the movement of this z axis is controlled by this vertical motion of this spindle. Okay, this vertical motion is controlled here in this along this z axis, and this positive and negative directions of this motion, this positive x and this negative x, or this positive y, negative y, positive z and negative z, these directions of this motion of a tool relative to the table along these axes. Okay, here we can see positive x, negative x, and all these positive and negative coordinates are here given. Then this rotational axes are also about this linear axis is also possible. Okay, and this may be used for this coordinate system is used for this flat and prismatic parts. Okay, that means this object is here flat, and milling and drilling operations can be carried out on this work part. Okay, object. So in such application this system is used. Then for rotational parts, this if the component is in rotational motion, rotational part is there in turning operations such as turning operations. Okay, so it is okay. So in this for this rotational parts, the conventional coordinate system, that is x y z, as we seen before, that conventional coordinate system is used, but only x and z axes are there. Okay, y axis is not needed in this turning, that means in rotational parts, for rotational part this y axis is not needed. So this x, positive x and negative x, positive z and negative z are the axes that are needed here. So this is the work part and this is the motions of this object. Then again here motion control. Okay, second part is motion control. So, and in this motion control, the first point, it is point to point motion control. Okay, so this point to point is also sometimes called as a positioning system. Okay, this point to point system is also called as sometimes positioning system. So again, in this point to point, the objective of the machine tool control system is to move the cutting tool to a predefined location. That means the objective of this type of this control is this tool should be moved in a predefined locations. That means from this point A to this point B, then to this point C, then to this point D and E. In this way this tool should move in this predefined location. Okay. Then we can see here to move this machine table or a spindle to a specified position so that this machining operations may be performed at that point. Okay, at this point A, B, C, D. So we have to move this spindle or this table at these positions. Then therefore it is called as point to point, from point A to B, B to C, C to D, and E in this way. The machine operation is performed at that positions. At these positions only this machine operations are performed. Then moving at maximum rate from the point to point. As it is moving from point to point, so rate of this travel is maximum here. Okay. Then accuracy of the destination is also important here, but not the path. The path of this machine tool movement is not important here, because here point to point movement is important, and the operations should be carried out at these required points only, not at the not along the path. Okay, so therefore this accuracy of the destination is very important here at this point A, B, C, but not path is not that much important. An example of this type of this point to point motion control system is drilling option, drilling or boring or butching. Okay, so this is the example of the, or this is the good example of this type of the machine control. So again here we can see this is the starting point of this tool. Okay, from this point this tool should move in this way. This should come at this position 1. Okay, so once it is came at this position, so here that tool should operate their operation, and then again it should move to this position 2, then it should move to this position 3 and perform this operation. Okay, so therefore this point to point motion is required here. Okay, so this point to point motion is controlled in this cases. The second one, it is straight cut NC mode. Then in this straight control NC machines, okay, straight control systems are capable of the moving this cutting tool, okay, uh, parallel to one of the major axis. Okay, this tool should travel parallel to this one of the major axis, and at a controlled rate for suitable for the machining. This tool should move at a controlled rate, and it should be suitable for the machining. Okay, we can see here in this mode of this cutting tool is moved parallel to one of the major axis. Here parallel to this one of the major axis, either it may be X, Y, or Z axis, and at a controlled rate. Okay, this rate should be controlled. Then pocket milling is an example of this straight cut NC tool machine mode. With this type of NC system, it is not possible to combine movements in more than one single axis direction. Okay, so that means it should be controlled in one direction only. So therefore, angular cuts on this workpiece would not be possible with this straight cut NC mode. Okay. Then next one, it is continuous path system. Third one, it is continuous path system. To control not only the dimensions but also the path through which the tool reaches this destination. So therefore here, in order to control this, not only the dimensions but also the path, okay, tool path that means that reaches this destination of the tool. Okay, here this linear as well as this circular or along this path this tool should move, and this should be controlled along this continuous path. Okay, then this you use linear and circular interpolators. For example, milling and turning operations may be possible with this type of this motion control motion. Okay, that means straight movement is also there, as well as along this tool path this movement should be there. Then fourth one, it is contouring NC control. Control Contouring is the most complex, most flexible, and the most expensive type of the machine tool. Then it is capable of the performing both point to point and straight cut operation. Okay, this type of this contouring NC system is capable of the performing both point to point as well as this straight cut operations. Okay, and in this mode the tool motion is more than one axis. Okay, is controlled continuously and simultaneously to get this desired shape. Okay, in order to get this desired shape, required shape of this object, here we can see this is the desired required shape. Okay, in order to get this we can perform this contouring NC control. Then this mode performs two-dimensional as well as three-dimensional profiles. Okay, here we can see this along this axis X, then along this axis Y, and along this axis Z also. This performs the 2D 3D dimension profiles to be control machines. Okay, used in milling and turning or grinding operations also. This type of this control is used. Then again, in this process of machining, the tool contacts the workpiece. In this process, this tool contacts or comes in contact with this workpiece and use linear and circular interpolators here. Okay, this uses the linear interpolators as well as this circular interpolators here. Okay. Also, in order to machine a curved path in a numerical control contouring system, the direction of the feed rate must continuously changed, okay, so as to follow this path. This direction should be continuously changed so as to follow this required path. Okay, so circular path or linear path, it should follow this path. This is the contouring of this NC control. Then here we can see control loops. Okay, after this motion control, next part it is control loops. Okay, so according to this control loops, there are two types of this control: open loop and closed loop control. Okay, so in this open loop, no position feedback is there. Okay, so that means this tool work head or this work part position, work table position, okay, there is no relation or there is no feedback comes from this to this controlling position, okay, or this input position. But in case of this closed loop, to measure this displacement of the table motion or this displacement of this tool motion, and this advantage of this closed loop system is it controls or it takes this feedback in from this optical encoder and it gives this feedback signal to this input system. Okay, this comparator input system is provided here, so therefore this it provides this inputs feedback to this inputs so that we can control again this numerical control machine. Okay, this is called as closed loop and it is the open loop system. Then power drives. According to this power drives, there are three main types. One, it is called as electric motor drive, then hydraulic drive system, and pneumatic drive system. In this electric motor drive system, this is most widely used electric drive system. Okay, and as it is small, it is easy to control and low cost drive system. So this electric motor power drives is mostly used. Then hydraulic drive system is used where this larger power is required. Okay, and it's the size of this size ratio is increases here. And also this pneumatic type of this drive is very rarely it is used in this NC positioning system and can be used to drive the auxiliary devices only. Okay, this pneumatic drive is very rarely used. So in this lecture we discussed all about this numerical control machine tool, NC machine tool, their classifications. Okay, then their motion controls, point to point motion control, straight NC control machine, then contour control. Okay, as well as this their coordinate systems of this NC machines. Okay, and thank you so much.